Quadratic formula. How to use it. What is it? The quadratic formula helps to solve any polynomial function with degree of 2. Why? It helps to find the value of profit gained. Interesting fact. VAT saves the U.S. agriculture industry $3.7 to $53 billion per year. Now, let's take a look at the definition of a quadratic function. It is f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers, where a does not equal 0. Now, let's start off with a quadratic function equal to 0, and work our way to the quadratic formula. Remember, the quadratic formula tells us the zeros of a function, so x is equal to something. So we need to solve for x. Let's take a look at what we have. Ax squared plus bx plus c is equal to 0. So we have two x's on the left side, and we only want one. So we have to use the complete the square method to solve for x. Let's start this proof by subtracting c on both sides. So now we have ax squared plus bx is equal to negative c. Now, let's divide each term by a so we can make the coefficient in front of x squared 1. So now we have x squared plus b over a x is equal to negative c over a. Now we're going to divide the coefficient in front of x, b over a, by 2 and square it. We are doing this because we want to be able to factor this. So we must add b over 2a squared on the left side. Since we added it on the left side, we must add it to the right side as well. So now we have x squared plus b over ax plus b over 2a squared is equal to negative c over a plus b over 2a squared. Now we can factor the left side to the quantity of x plus b over 2a squared, and that is equal to negative c over a plus b over 2a squared. We have completed the first part of the proof. Let's move on to the second part. Combine like terms. We're only going to work on the right side for part 2. Now, let's simplify b over 2a squared to b squared over 4a squared. So now we have negative c over a plus b squared over 4a squared. Next, we're going to multiply negative c over a by 4a over 4a, so we can have a common denominator. So now we have negative c over a times 4a over 4a plus b squared over 4a squared. Let's mash those numbers together, and the result is negative 4ac over 4a squared, and we still have plus b squared over 4a squared. Now, let's rearrange the terms so b squared over 4a squared is first, followed by the negative 4ac over 4a squared. Now, let's combine the terms together, so now we have b squared minus 4ac over 4a squared, and that is still equal to the quantity of x plus b over 2a squared. We have completed the second part of the proof. Let's move on to the third part. Solve for x. So let's take the square root on both sides. So the left side simplifies to the quantity of x plus b over 2a, and the right side becomes plus or minus the square root of b squared minus 4ac over the square root of 4a squared. We used the quotient property of square roots so we can simplify the denominator. Let's drop the parentheses on the left side and simplify the square root of 4a squared to 2a. So now we have x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac over 2a. Let's subtract b over 2a on both sides. So now we have x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Finally, let's combine the terms, so now we have the quadratic formula. We have completed the proof on where the quadratic formula comes from. Now, let's focus on the previous step. What other formula do we think this looks like? Is it becoming clearer now? Remember, the standard quadratic function is ax squared plus bx plus c. And we can find the axis of symmetry using the formula x is equal to negative b over 2a. Let's write down the step that we boxed. X is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. So what does the plus or minus the square root of b squared minus 4ac over 2a represent? That is correct. That is the distance the x-intercepts are from the axis of symmetry, where the one on the right is adding and the one on the left is subtracting. So our first x-intercept is negative b over 2a plus the square root of b squared minus 4ac over 2a. And the second x-intercept is negative b over 2a minus the square root of b squared minus 4ac over 2a. Now, let's take a look at the examples we're going to discuss in today's video. Let's take a closer look at example 1. Now, let's read the steps. Step 1. Solve for 0. Step 2. Find a, b, and c. Step 3. Use the quadratic formula. Step 4. Simplify. Now, let's read the question. Solve the following equation, where we have 2x squared plus x minus 15 is equal to 0. Let's write down our equation so we can show our work. Since we're solving for zeros, we want one side to be 0. Our equation already has that, so we don't need to move any terms around. Let's rewrite our equation as 2x squared plus 1x minus 15 is equal to 0, so we can see the a, b, and c values easier. So a is equal to 2, b is equal to 1, and c is equal to negative 15. Now, let's write down the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, let's substitute 2 for each a, 1 for each b, and negative 15 for each c. So now we have negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 15 over 2 times 2. Let's multiply. 1 squared is 1, and negative 4 times 2 times negative 15 is positive 120, and 2 times 2 is 4. So now we have negative 1 plus or minus the square root of 1 plus 120 over 4, and 1 plus 120 is 121. So now we have negative 1 plus or minus the square root of 121 over 4, and the square root of 121 is 11. So now we have negative 1 plus or minus 11 over 4. So we can break that into two parts. Negative 1 plus 11 over 4, or negative 1 minus 11 over 4. Let's start with negative 1 plus 11 over 4. Negative 1 plus 11 is 10. So now we have 10 over 4, which simplifies to 5 over 2. So x is equal to 5 over 2, or let's find out. Let's continue with negative 1 minus 11 over 4. Negative 1 minus 11 is negative 12. So now we have negative 12 over 4, which simplifies to negative 3. So x is equal to negative 3. So x is equal to 5 over 2, or x is equal to negative 3. That is example 1. Let's move on to example 2. Now, let's read the question. Solve the following equation, where we have 2x squared plus 6x is equal to 9. Let's write down our equation so we can show our work. Since we're solving for zeros, we want one side to be 0. Our equation does not have that, so we need to subtract 7 on both sides. So now we have 2x squared plus 6x minus 7 is equal to 0. Now, let's label our a, b, and c values. So a is equal to 2, b is equal to 6, and c is equal to negative 7. Now, let's write down the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, let's substitute 2 for each a, 6 for each b, and negative 7 for each c. So now we have negative 6 plus or minus the square root of 6 squared minus 4 times 2 times negative 7 over 2 times 2. Let's multiply. 6 squared is 36, and negative 4 times 2 times negative 7 is positive 56, and 2 times 2 is 4. So now we have 6 plus or minus the square root of 36 plus 56 over 4, and 36 plus 56 is 92. So now we have 6 plus or minus the square root of 92 over 4. And the square root of 92 is not perfect, so we have to break it down. Let's divide 92 by 2, which is 46. Let's divide 46 by 2, which is 23. We can't go any further since 23 is prime. So we have the square root of 2 times the square root of 2 times the square root of 23, which is the square root of 4 times the square root of 23, which is 2 square root of 23. So now we have 6 plus or minus 2 square root of 23 over 4. Most of the time, this would be our answer, but in this case it is not, since we can simplify. Let's write it again so we can show our work. Right now, we have one fraction. Let's break it down into two fractions so we can see easier how to simplify. So now we have 6 over 4 plus or minus 2 square root of 23 over 4. And 6 over 4 becomes 3 over 2, and 2 square root of 23 over 4 becomes square root of 23 over 2. So now we have 3 over 2 plus or minus the square root of 23 over 2. Let's combine our fractions. So now we have 3 plus or minus the square root of 23 over 2. This could be our answer, or if we want, we could break it down into 2. So we have x is equal to 3 plus the square root of 23 over 2, or x is equal to 3 minus the square root of 23 over 2. That is example 2. Let's move on to example 3. Now, let's read the question. Solve the following equation, where we have 3x squared minus 4x is equal to negative 5. Let's write down our equation so we can show our work. Since we're solving for zeros, we want one side to be 0. Our equation does not have that, so we need to add 5 on both sides. So now we have 3x squared minus 4x plus 5 is equal to 0. Now, let's label our a, b, and c values. So a is equal to 3, b is equal to negative 4, and c is equal to 5. Now, let's write down the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Now, let's substitute 3 for each a, negative 4 for each b, and 5 for each c. So now we have the negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times 3 times 5 over 2 times 3. Let's multiply. The negative of negative 4 is 4, and negative 4 squared is 16, and negative 4 times 3 times 5 is negative 60, and 2 times 3 is 6. So now we have 4 plus or minus the square root of 16 minus 60 over 6. And 16 minus 60 is negative 44. So now we have 4 plus or minus the square root of negative 44 over 6. And the square root of negative 44 is imaginary, but we can still break it down. So now we have the square root of negative 1 times the square root of 4 times the square root of 11. And the square root of negative 1 is I, and the square root of 4 is 2. So now we have I times 2 times the square root of 11. And that is 2i times the square root of 11. So now we have 4 plus or minus 2i square root of 11 over 6. Most of the time, this will be our answer, but in this case, it is not, since we can simplify. Let's write it again so we can show our work. Right now, we have one fraction. Let's break it down to two fractions so we can see easier how to simplify. So now we have 4 over 6 plus or minus 2i square root of 11 over 6. And 4 over 6 becomes 2 over 3, and 2i square root of 11 over 6 becomes I square root of 11 over 3. So now we have 2 over 3 plus or minus I square root of 11 over 3. Let's combine our fractions. So now we have 2 plus or minus I square root of 11 over 3. This could be our answer, or if we want, we could break it down into 2. So we have x is equal to 2 plus I square root of 11 over 3, or x is equal to 2 minus I square root of 11 over 3. That is example 3. And now it is your turn. So go ahead and pause the video here so you can take your time to answer this question, and I'll show you the result in 3, 2, and 1. Did you get it correct? Fantastic. If not, there's always tomorrow.